Hi, I'm Bob Tabor with LearnVisualStudio.net. At this point, we are recording audio and we're saving it as a temp file to our app's isolated storage area. So next what we need to do is allow the user to say, I want to save that permanently. I want to make that available as one of my tiles in the custom sounds pivot of the main page.xaml so that I can use that sound in the future, right? So our game plan in this lesson then is to, first of all, we're going to need to allow the user to save a temporary file permanently. We're going to pop open a little dialog and it will allow them to give us a name, and we're going to save that name into a file somewhere along with the location of the custom sound. So let's break that down into a couple of steps. We've already got an application bar that we've added to our project in a previous lesson. You remember the application bar button that had the little disk icon, right? So now we want to enable that, and we're going to create an event handler. So when somebody clicks on that save button, then we can kick off the save process. We're also going to want to manage the state of the application bar as a whole. I mean, it should only be visible if there's a temporary audio file that's been created and it's ready to be saved permanently. So once somebody clicks on the Save Application Bar button, we want to then open up a dialog and say, give us, the word that you, or the phrase that you want on the title, on the tile of our custom sounds pivot items, right? And so we're going to use the Coding for Fun toolkit once again. It'll allow us to display an input dialog that'll capture the name from the end user of the new custom sound audio file. So now we have a name and we have a location for this file. We're going to need to save those bits of data off so that every time we start the app, we can retrieve those and create the custom sounds tiles. And when somebody clicks on them, we can play the sounds. And so to do that, we're going to use a file format called JSON, JavaScript Object Notation. We'll talk about that more in a little bit. But then finally, we'll need to modify our data model. So let's see where our view models are here. Oh yeah, we're going to modify the sound model's load data method to retrieve that JSON file, parse through its contents, create the appropriate sound data objects to represent each item that we've saved off in our JSON file, so that it then displays the tiles that represent those sounds on the custom sounds pivot item on our main page.xaml. Phew, that sounds harder than it really will be, I assure you. Okay, so let's go ahead and get started. First thing we want to do is we're going to work with that application bar button that we created earlier. You can't see it here because we actually created it in our build localized application bar method here. And we turned off this application bar is visible equal false. Let's go ahead and turn that back on because we don't want to show it right away. Instead, what we're going to do is only show it when we have data, when we have a sound that's ready to be saved permanently. First of all, though, we want to only display our localized application bar, so this app bar, we only want to display it once the record audio toggle button is unchecked. So here we'll go application bar dot is visible equals true. Okay, equals true. All right, there we go. Okay, so let's go back to this here, and what we want to do is pop open a input prompt. So a little dialog on the phone that will allow the user to type in the name of this sound. So let's go input prompt file name equals new input prompt. And I'm going to want to add a using statement, and it is codingforfun.toolkit.controls. All right, and so the next thing that we're going to want to do now is to give that input prompt a title, sound name, and we'll give it a message to display. What should we call the sound? Then we'll add an event handler to the completed event of the dialog. So when the user finishes typing in the name for the file for the sound, and they click the little check mark on the dialog, then this event handler, file name completed, will be executed. Completed. There we go. And then finally, what we're going to do is go ahead and show the dialog. So what we're going to want to do here is we're going to want to make sure that the input prompt was exited properly by the user by checking the results. So we're going to check the pop-up result that was sent into this event handler as an input parameter. If the result is okay, then we can perform the logic necessary to save the temporary file as a new permanent file. So let's take a look at this and let's write that code. So if the pop-up result is popupresult.ok, then we're going to need to do a bunch of stuff. For example, here, let's make a list of to-do items here. We're going to create a sound data object so that we can add it to our collection of sound data objects for the custom sounds sound group. Next, we're going to want to save the WAV file into the directory. We're going to put all the permanent ones into a subdirectory called custom audio. And then we're going to add the sound data object to the app.viewModel.customSounds sound group. Then we're going to save the list of custom sounds to isolated storage. And we're going to use something new called application settings. This is really neat. It's basically just like any other isolated storage file that we created, like the WAV file, except it's specifically used for name value pairs, things that we want to save, just data. And there's a lot less overhead to doing this than writing a file every time. We can just say application settings, give it a new name, set it to a value, and then we can retrieve it out very easily. You'll see how easy this is in just a minute. And then we're going to need to modify our sound model to retrieve custom sounds from isolated storage application settings. All right, great. And then the final thing we're going to want to do is navigate back out to the main page. We know how to do that already, so let's go ahead and do that. Navigation service.navigate. And so we'll give it a new URI and give it a URI kind. Relative or absolute, we'll let you figure it out. And here we're going to go to mainpage.xaml. Great. All right, so let's see what we have so far. Let's go ahead and run the app. Let's fix any problems that we have with our code. Like so. That's from the previous lesson. Let's go ahead and run the app. And this is from the previous lesson too. Looks like we should have tried to compile it before. All right, there we go. All right, so let's try to record. Now notice there's no app bar. I'll click record. This is just to test to make sure this works. Notice that the play button has been disabled. When I click the record button again, the play button is enabled, and notice that the app bar comes up. I can play the sound, but I'm just going to go ahead and click the save button, and it's going to ask what the name of the sound should be. I'm just going to type in this is, whoops, let's go page down. This is just a test, and click the OK button, and now we're back to our main page.xaml. All right, so generally the flow is working. Now we just need to fill in all of the or take care of all these to-do tasks that we outline in the code comments, all right? So at this point, we have a custom sound that's recorded and stored as a temporary file, and we've just collected a friendly display name for that sound using the input prompt. So now we want to accomplish two basic tasks. First of all, we want to add the custom sound to our data model. If information about our new custom sound is never added to the data model, then we'll never be able to render it to the custom sounds view on our main page.xaml, right? So we're going to create a new instance of the sound data class, and we're going to fill in the file path and the title properties appropriately. And then the second task that we're going to need to do is to move that file from its temporary location to a permanent subfolder called custom audio, like I've outlined here. This is purely to keep all of our custom sound files organized in one place. So what I want to do in our file name completed event handler is, first of all, we're going to create a sound data object. So sound data. And we don't have that namespace added yet, so let's go ahead and add that. Soundboard.viewModels, great. Sound data equals new sound data. And sounddata.filepath equals, and what we'll want to do is we're going to take this tack like we did previously in another lesson. And we're going to use the datetime.now.toFileTime method once again. And so this time we're going to put this in the custom audio folder, and we're going to name it like that. All right. And so then we're going to also want to give this sound data a title. And that will be whatever the result was from the pop-up, from the input prompt from earlier that's passed in here. All right, and so we'll get to the result, whatever was typed in by the end user, and we'll put that into the title property of the sound data object. Great. All right, so the next thing we're going to want to do then is save that WAV file into the directory custom audio. So let's do that now. Again, when I'm working with a managed class that works with unmanaged resources, I'm going to want to use the using statement. All right, so let's go ahead and set that up. So we're going to do a using isolated storage file, again, isostore equals isolated storage file dot get user store for application. All right, and then inside of that, if isostore directory exists. If it doesn't exist, custom audio, then we're going to create it. So isostore dot create directory. Whoops, create directory. Custom audio. Great. And then we're going to isostore dot move file. We're going to take the temp file name, so what it was previously called, and we're going to move it to the sounddata.filepath. All right, hopefully that makes sense. If the directory in our isolated storage area doesn't exist, go ahead and create it, and then we're going to move the temporary file name that was created when we were saving the temp audio, and we're going to move it to this new place, the new file path, which is essentially the name that's constructed using the toFileTime of our datetime object, and we're going to put it in that folder that we just created here, or if it doesn't already exist. All right. So then the next step is to add the sound data to the app view model custom sounds. All right, that's easy. So app.viewModel.customSounds.items.add and sound data. Perfect. Great. So this should work right now. Let's go ahead and run it just to make sure. This is another test just to make sure this works. save it. First test. Whoops. Looks like it's not. Okay. Problem here is that custom sounds has not been created. I know how to remedy that pretty quickly. Let's go to the sound model class. So when we were doing all this work here, we never created a new sound group for custom sounds. So let's go ahead and create that now. And we'll get rid of this later, but this should work for now. Okay, so let's try it this time. Okay. This is just a test to make sure this works. Save it. Second test. Okay. And now, if we're lucky, hey, look at there, second test. Now we have some problems here. Obviously, we don't have the correct name for this pivot item because, well, we are taking a shortcut here. I probably should have created one of these helper methods for it, and we're going to get to that in just a minute. But I think the bigger issue here is what's going to happen when we close the application and it's completely removed from the phone's memory. When that happens, the custom sounds items collection is going to be removed from memory, and the next time the app is run, it'll no longer have the memory of our custom sounds. So we need a way to store custom sounds data so that we can load it into our data model the next time that the user runs our app. So to do this, we need to serialize our custom sounds items, so these custom sounds items right here, into a data format. And there are many data formats that we could choose, but we're going to pick a very popular, lightweight, easy to use format called JSON. It's short for the JavaScript Object Notation. It allows us to easily represent our collection as JavaScript objects. Now, if we utilize a third-party open source library called JSON.NET, we won't even have to think about the data's format at all. And much of that complexity will be completely hidden behind simple method calls. So that sounds great to me. So to begin, what we're going to do is open up the NuGet Package Manager using the technique that I demonstrated earlier. I'm going to right-click References and select Manage NuGet Packages. And this time in the search, I'm going to look for JSON.NET. And it'll be one of the first options at the very top. I'm going to click Install. And after a few moments, it'll be added to our project. You can see the little check that this package has already been installed. That's good. Click the Close button. And now if we take a look in our References folder, we can see that we do have newtonsoft.json. Great. So we are ready to go. So back here in this file name completed method event handler, what we want to do is convert the custom sounds items to JSON and then store it to disk. So we're going to use the newtonsoft.json.json convert class to perform the conversion. So let's go here and start with var data equals JSON convert. All right, and let's go ahead and hover over and select using newtonsoft.json. Great. And now what we're going to do is go serialize object, and we're going to pass in the app.viewModel.customSounds. So this will take a collection and serialize it down to JSON format. And now we have the data, all the items, basically all of the sound data objects that belong to the sound group called custom sounds in a JavaScript object notation format. Great. So the next thing that we need to do then is actually save that collection, that JSON file or data to disk. And so this is where we're going to go isolated storage settings dot application settings, and we're going to index into it something called we'll call this custom sound key, and we'll get back to that in just a moment, equals data. And then isolated storage settings dot application settings dot save, and that will save our data to disk. So we basically just came up with a key called custom sound key, and now we can retrieve our custom sound key, what it's associated, all that JSON data, and now it'll be saved to our isolated storage in a little container that will hold name value pairs. The name will be custom sound key, and the pair or the value will be the data, the JSON data. Okay. All right. So let's do this. I don't like to use magic strings like this. I just did it for illustration's sake. Let's go ahead and remove that from there, and instead we're going to go to our sound model, and we're going to create a new public property, actually a public const string custom sound key equals custom sound. And a constant is basically just a string that we don't intend to ever change the value of, and that'll just enforce that to make sure that the value's never changed. And we want consistency across our entire app, so that's why we'll create it as a constant and use it as a property of this class. So back here in our record audio.xaml.cs, we're going to go sound model dot custom sound key. All right, beautiful, and that will enable us to set, and then we can retrieve using that same key. Okay, so we're saving our list of custom sounds to isolated storage. Now we need to retrieve them every time that we load data. So let's go back to our soundmodel.cs, and here where we do all of this work, what we want to do is reset this. Custom sounds equals load custom sounds, and we'll create a new helper method for that purpose. So let's right click it and select generate method stub. Great. And then inside of here, let's go ahead and retrieve that that data from isolated storage settings into our custom sound group. Okay, so here we go. So we know we're going to need a sound group, and what we're going to do is if isolated storage settings, let's go ahead and add that using statement so we get the benefit of IntelliSense here, dot application settings dot try get value, and so we'll use that custom sound key that we created just a moment ago. If it actually has anything in it, then we want to retrieve it out. So we'll retrieve it into a new variable. I'll call this a variable data from app settings. So let's go ahead and create that. So string data from app settings. Okay. So if we're able to retrieve that out successfully, it'll not only be stored here, but will also then perform whatever's inside of this code block. So then if we're able to retrieve it out, then we're going to go data.json convert. So again, we're going to have to add a using statement for newtonsoft.json. JSON.convert deserialize object. Okay, last time we serialized it. This time we're deserializing it. And we're going to use one of the versions of deserialize that allows us to pass in or tell it what type we expect to deserialize this information into. In this case, we would expect it to be deserialized into a sound group. And then we'll pass in the data that we retrieve from the isolated storage settings. In this case, that is data from app settings. Okay. All right, so if we were able to successfully find that value, custom sound key, we'll be able to get the data out, the JSON data out, and then we'll deserialize that JSON into some data. But what if it doesn't exist? Then we'll just need to set data equal to new sound group. It'll be empty. And we'll give the data title equals mine. Okay. And return data. I could have called this custom sounds. The idea here is that we want to set up the title for this sound group, and we'll do it the very first time that the user uses our app, and then from that point on it'll be serialized and retrievable through here, right? So, okay, let's go ahead and see where we're at so far. I'm going to rerun the app and try this whole process. So here we go. Here's another test. I'm going to save it. Call this third test. All right, and now let's go over to mine, and there it is. Now let's try to hear third test play. Uh-oh, it doesn't play. All right, that's because we need to modify the playback code on the main page.xaml to load custom sounds from the new folder. Currently, it's only loading sounds from the assets folder. So let's go here to our main page.xaml.cs. And so the goal is to set the media element source property with the correct location of the sound file associated with the tile that our user tapped. And we'll look in one of two places, either in the assets folder or in the isolated storage area. So in the main page.xaml.cs, in the long list selector underscore selection change event handler method, we'll want to add the following right here, where we're currently setting the source for the audio player. We're going to need to add two possibilities. If the file exists, so here we go, if file, and we're going to need using system.io, so if file.exists, so we're going to look on isolated storage and see if it exists, data.filepath, then we'll set the audio player. We'll basically just take this line of code right here. Okay, so that's the case that we currently have working now. But what we want to say is, if we can't find it in the assets folder, all right, then what we need to do is look in a different spot. So using var storage folder equals isolated storage file dot get user store for application. Okay, and let's make sure we get the correct using statement here. Great. Then we'll want to add another using statement. So and get the stream equals new isolated storage file stream data.filepath file mode open, and then we'll give it the storage folder. And then finally, we should have what we need, audio player.setSource, and we'll give it that stream. Great. All right, this is going to require a little explanation here, what I did. So the purpose of this if statement is really to see if the tile that's been selected by the user is a custom sound or not. So if we can't locate the file name associated with the tile in the assets folder, then we're going to need to look for it in the custom sound subfolder in the app's isolated storage area. Okay, so in this case, remember, the file wasn't found in the assets folder, so we're going to search for it in our isolated storage. So we create a reference to the isolated storage for our app, and here we get access to the file using a new technique. We're opening the custom sound as a stream, and basically, or in other words, an isolated storage file stream. This is basically the antithesis of what we did earlier when we wrote from a memory stream into a file stream. Now we're pulling out from a file stream into a memory stream, okay? So essentially, just think of this as the exact same thing of what we talked about before with regards to buffers. It's just there so that we can retrieve data out that's coming out at one speed so that we can process it at a different speed. That's all it's there for. And every time you work with file systems or networks or things of that nature, you're going to work with some sort of buffer, and that's all we're doing right here. Okay? And so here then we set the source of the audio player to this stream, this file stream that we have specified by the file path. We're saying open it up, and it should be located in this folder. Which folder? The isolated storage folder of our device for this app. Okay, let's go ahead and rerun the app. All right, and so this time, whenever we record the audio, this is just a recording once again, and we go to save it. What is this, the 5th try? I lost count. And click the OK button. Now when we go to the mine, 5th try is there, and it should play. Record the audio. This is just a recording. And it does play. Once again. Okay. Boy, so we did a lot of work here. To recap, the big takeaways from this lesson were serializing and deserializing objects into JSON using the Newtonsoft JSON library, which is a very valuable skill that transcends phone development. We also learned how to work with isolated storage, particularly the isolated storage settings to store name-value pairs. We used the system.io.file class to examine the file system and determine whether the file was where we expected was or not. If it wasn't, then we learned about working with streams, file streams, which are just another type of buffer. We also used the input prompt from the Coding for Fun toolkit, and we did a bunch of other things as well. All right, the good news is that we're almost done with this. We're just going to need to add one last touch to make the app fun to use, and we'll do that in the next lesson. We'll see you there. Thank you. Hi, I'm Bob Tabor with LearnVisualStudio.net. The final step is going to be a lot of fun. We're going to animate that real object on our record audio XAML page. And we want it to rotate while we're recording. I think that's going to be a nice visualization of what the app is actually doing. A nice visual cue to the user that they're in the middle of an important operation in the app. So our game plan in this lesson will be, first of all, to create a storyboard that includes an animation that will rotate the ellipse, really everything in that grid that contains the ellipse, the smaller ellipse, and the little squares. And then we're going to programmatically start and stop that animation. But first we're going to need to learn a little bit more about creating animations on the Windows Phone. So before we dive too deeply into the topic of animation, I want to discuss it at a very high level. Once we're comfortable about how animation works in XAML UI frameworks, we're going to have a bit more confidence to apply a specific animation to rotate our reel. So first, it's important to realize that XAML controls like the grid and the button and so on, they're defined separately from animation definitions. You can create an animation that's applied to different controls as needed. An animation is associated with a control, and then it's triggered by some event. Now in our case, we've already defined the grid and the shapes that will comprise our reel, and soon we're going to define an animation and then associate the animation with our grid and all the little bits inside of it. And then we're going to write C# code to trigger the animation. So again, we're going to do all this before the end of the lesson. Animations are made up of a storyboard object and at least one animation object. So let's start with the animation. First, there are several different types of animation data types. We're going to use a double animation data type because we want to move a property, specifically the rotation property, from 0.0 to 360.0, the angle of the animation every several seconds, okay? In other words, we want the grid to rotate, let's say every 4 seconds, completely 360 degrees. So each fraction of a second, we want the rotation property to increment in even fractional amounts to make it appear like it's animated. So besides the double animation object, there's also a color animation class for animating between two colors, a point animation class for modifying an object's XY coordinate or its size. So an animation is basically a timeline combined with a result. The results are determined by the specific animation class that you pick, like we just talked about, a double animation, a color animation, and so forth. It's important to know that all animation classes inherit from a timeline class, which confers properties related to the timing of an animation. The begin time, that allows you to kind of delay the start of the animation, perhaps waiting for other animations on the storyboard to begin or to complete. A duration property that affects how long the animation should take before delivering the desired result. There's also an auto reverse and repeat behavior property, which do what they suggest. Should it animate one way and then animate all the way back to the original value? Should it continue to repeat forever, and so on? So a storyboard is a collection of one or more animations. You group the animations that you want triggered by a specific event, like a button click or a loaded event, and so on. The storyboard allows you to pair an animation with a target object. The animation is just a definition of what property should be affected, when it should be affected, and for how long. We then have to apply that animation to a target object. Now in our case, that target object will be that grid that contains all of the shapes that represent the reel. In our case, our storyboard will be simple. We just want one thing to happen, a rotation from 0 to 360 degrees every 4 seconds. We could add multiple animations targeting multiple properties of multiple objects, and we could even create child storyboards to better refine how our user experience will play out. Then once we're ready to allow the storyboard to play, we'll call its begin method. So it'll in turn kick off all of its child animations and child storyboards. So there's 4 possible transformations or transforms that you can animate as listed and diagrammed on this page that you see on screen right now. And I realize that this article is specifically for WPF. However, many of the concepts that I described above and we'll talk about in this lesson are transferred to the Windows Phone API and any XAML-based UI framework. Okay? So the 4 possible transforms are the rotate transform, the scale transform, the skew transform, where you can like make things, the shape and the size of different portions of the shape change, and then a translate transform, as well as other attributes that you can change with, like, for example, the color animation and so on. And there's a lot more to learn about animations, and for a more complete explanation of animations, I would recommend that you start here on the page that you see on screen right now. So now that you have the very, very basics of storyboards and animations, let's modify the grid containing the shapes that comprise our real graphic. You'll recall that the large ellipse and the smaller rectangles and ellipse are contained in a grid for layout purposes, this grid right here. All right, so to get them to move all correctly at the same time, it's easier to just animate or rather to rotate the grid rather than animate each individual shape. So that's one reason why we put them in the grid control in the first place. So what we want to do is add a name for the grid. So let's call this real grid. Okay, and so then we can access it programmatically. And I want to indicate that I want to animate the entire grid and all of its children to animate together as a group, or rather as a composite. So what I'm going to do here is actually add grid.render transform, and I'm going to set that to a new instance of the composite transform. Again, I want the whole thing, the grid and all of its contents, to be treated as one unit for the purpose of animation. That's what this does. Or more specifically, this composite transform does, okay? All right, so near the top of the record audio page, beneath the phone application page declaration, right here, what I want to do is add a resources selection. We've done this before. So let's go phone application phone application page dot resources. All right, very good. And then inside of there, I want to define a storyboard. All right. So storyboard, and I'm going to give it a name. And then I'm also going to give it a repeat behavior of forever. And inside of the storyboard, I'm going to create an animation, a double animation. I'm going to set its duration equal to 4 seconds, so 0:0:4. And I'm going to set it to the value of 360. And there will be some other things I'm going to set here, and let me just type them out, and then I'll explain what they do in a little bit. So the target property will be the UI element. And then the storyboard dot target name equals real grid. And we're going to go and set this. Okay. Okay, so let's start over again. We're creating a page level resource. We're creating a storyboard. Okay, so let's start over here. First of all, we are creating a page level resource. Specifically, we're creating a storyboard, and because it's page level, we could reuse this in other spots on our page if we really wanted to, but we don't really need to in this case. We're going to give the storyboard a name, rotate circle, and this will allow me to access it programmatically. And once we start the rotation, or we start this storyboard rather, we want it to repeat forever until we tell it to stop. All right, so we build next a double animation object. Why double animation? Well, as I discussed at the outset, we want to modify the rotation property, or more specifically this storyboard.target right here, from 0 to 360, which are numerical, and therefore we require the use of the double animation object. And we set the duration to 4 seconds. So in 4 seconds, we want to increase the rotation value starting at 0 and increasing to 360. So then we set the target name and the target property. The target name, which is our grid here, right? That contains all of our ellipses and rectangles. Now the target property is a little bit tricky. We have to write it this way due to the fact that we're working with a composite transform. And as I mentioned ago, we want to animate the grid and its children. Otherwise, we could simply set the target property equal to rotation. But here we want to set it equal to a render transform and the composite transform.rotation, pretty much like what we've done here with render transform, composite transform, and specifically we're going to composite transform the rotation property. All right, so what comes next is easy now that we've declaratively defined the animation. We're going to start and stop the animation based on the state of the toggle button. So let's go over to our recordaudio.xaml.cs, and in the record audio checked, what we want to do is call rotate circle.begin, and then in the record audio unchecked, we're going to call rotate circle.stop. All right, and I just noticed something here as I was typing this. We have we set the application bar as visible equal to true here. We need to set it equal to false when the record audio button is checked. So I'm going to go ahead and add that line of code as well in order to help manage the state of things better. Okay, so just a little bug fix there while we're here. All right, so if we would run the application at this point, we would notice an odd behavior during. All right, so let's go ahead and click the record button. And now when we click the toggle button, notice the odd behavior. The reel is not rotating in place, but rather it's rotating around the page. This is because we didn't define the spot of origin for the transform to take place. Instead, it's at its default XY position, which is in the upper left-hand corner. And instead, what we want it to do is be in the middle, the origin of the transform to be in the middle. So instead of 0.0, we want it to be at 0.5 and 0.5 for the XY position. So what we'll do here, let's go ahead and stop running the app. And in the grid that contains our reel, we want to add, here, let me just move these down to other lines. We're going to add the render transform origin, and we're going to set that to 0.5 and 0.5. All right, so now when we run the app a second time, and we try to record, okay, and now we get the rotation that we expect. Very cool. Awesome. Okay. Now, just for fun, I'd like to get this working on my Lumia 920. So what I want to do is go ahead and connect the USB wire with my phone, because I'm anxious to try this out. And you can see, let's see what happens here. No, I'm good. I don't need to do any of that stuff. All right, let's go ahead and switch over to the device. And I'm going to go ahead and, whoops, I know I'm going to need to unlock it. There we go. Hopefully we're good. Okay, so it came up on my phone. So now I can play any of the sounds, like, let's go for a horse gallop, or dog actually. Awesome. And now let's record one of our own sounds. Well, actually, let's click the record button. This is just a test to see if this works. And let's play back.
This is just a test to see if this works.
Awesome. Let's give it a name. All right, we'll just call this Bob. And click OK. And now I should be able to see it.
This is just a test to see if this works.
Awesome. That's so gratifying to get it deployed on your actual phone and to see it working. Okay, so that was a lot of fun. Okay, so to recap, in this lesson we learned about animation using a storyboard, and we talked about how storyboards are related to animation classes. We talked about the different types of animations and transforms that you can add to your app. We learned how to programmatically trigger the storyboard to start it and to stop it. We learned about things like how to modify the rotation animation starting point by changing the render transform origin attribute from the upper left-hand corner to the middle so that it rotates in place and rather than rotating around that starting point. But the big takeaway is that if you can imagine it, there's likely a way to accomplish it given the wealth of animation options in XAML and the Windows Phone API. Okay, so now that you've finished your first version of this app, I want to challenge you to add some functionality to this app on your own. Now again, struggle is how you learn, so there's no doubt that what I'm asking you to do here will be hard, and I'm going to leave you to do it on your own. And I haven't added these features myself, and there's no denying that they would probably require me a couple of days to research, develop, and debug these features. But here's what I would like you to try and add. 3 things. First of all, I want you to figure out how to add images to each item, each tile. So you need to manipulate the data model to accommodate an associated image file with each sound data object. So you're going to have to add image files to the project. You'll have to add an image control to the data template, and then figure out how to bind the image's source to your sound data object. So, you know, if you actually watch the rest of the series, you're going to get some hints on how to accomplish this, because we're going to be binding images to tiles, among other things, as we create our second full-fledged app here in just a moment. The second thing I want you to figure out is how to delete items. So right now there's a huge limitation in this. If you add a custom sound, there's no way to get rid of it. You're stuck with it for the rest of your life. I'm going to have that Bob test sound on my phone now forever. That's an unfortunate limitation. Clint suggested that you use the context menu from the Windows Phone Toolkit. I'm not sure, but I think we might be using that as we work on the next app, but I'm not 100% sure. But look up the context menu on the Windows Phone Toolkit. And then the third thing I want you to try to figure out is how to pin individual sounds to the start page. Honestly, that's something I've never tried to implement, but I know there's tutorials out there that can lead you in the right direction. So if I want that dog sound on my start page, how would I pin just that sound to my start page? All right. And hey, are there other cool ideas, cool features that you would like to see added to this app? Try adding them yourself, or tell you what, share them below in the comments area for this video as challenges to your fellow students, and see if somebody can come up with it and challenge each other. That'd be a great way to build a community around this learning experience. All right, but we have to move on. What I want to do next is actually show you how to submit this app to the phone store for inclusion and for sale, or give it away for free. And so we'll do that in the next lesson, then we're going to move on to our next project. So we'll see you there. Thank you. Hi, I'm Bob Tabor with LearnVisualStudio.net. Now that we've finished the app, it's time to test it and submit it to the store. Now, a word of caution before we continue. At a minimum, your users expect your app to be solid and look professional. With regards to creating a solid user experience, there's only so much you can do by yourself because you have the curse of knowledge. As the developer, your knowledge of the flow and the normal operation of the app creates a certain myopia. You'll quickly find that your users will break your app in new and creative ways. So I would spend some time thinking about the states of the application, particularly any scenario that accepts information from the user in input controls or dialogues. And I would spend some time thinking about exception handling and messages back to the user to help diagnose the problem. I would think about inputs and outputs in edge case scenarios. What if they use strange characters outside of the normal ASCII or extended ASCII range? What if they add two sounds with the same name? What if the program runs out of battery while the user is recording a sound? What if the user clicks one of the hardware buttons while recording or playing back a sound? What if the user fills up isolated storage with custom sounds? Well, as it stands now, that would be a real problem because we don't have a delete sound feature in the app, okay? So with regards to a professional appearance, here again, you have the curse of knowledge, and quite possibly you have a cognitive bias that leads you to think that the flow and the aesthetics of the app look great when your users may think otherwise. So getting feedback, especially from somebody who may study design and usability and so on, that could prove invaluable. I'd get them involved as early and often throughout the development process as possible. The beauty of the Windows design language, formerly known as Metro, is that it pushes you towards a certain aesthetic sensibility. You should study the recommendations from Microsoft in this regard at this URL. I found this to be a great resource. At any rate, even when you're getting creative and you're thinking through the functionality of your app, you're going to miss something. That's why it's good to do a couple of things. First of all, let others see your work, especially those who are not your close friends or family. You want honest feedback. Your family and friends don't want to hurt your feelings if they don't like your work, so they're not going to really tell you what they think. So you need to get some unbiased feedback. Secondly, you want to use the beta test feature of the store before you attempt to sell the app. Now you're opening up your app to more scrutiny and more feedback. However, it's better that you hear that feedback in beta rather than you hear that feedback in the form of negative reviews that pour in and kill your app's chance at success. And then third, even after you sold the app or even if you distribute it for free, be responsive to customer emails, any questions that they might have, any feedback that they might have. Whether you realize it or not, once you publish that app in the store, you're now running a business. And from now on, you need to be the friendliest guy on the planet. If somebody asks for a new feature, ask them for more details and be genuinely interested and give some serious thought to whether that's a viable feature to add or a bug fix, all right? If somebody's frustrated and they use harsh language or tone against your app, well, you gain absolutely nothing by returning the salvo back to them. You need to grow a thick skin and swallow your pride and be the bigger person. From personal experience in handling customers who are displeased over the years, you can turn an enemy into a friend more often than not by choosing your words carefully. And I'd like to recommend to you the time-honored book, How to Win Friends and Influence People by Dale Carnegie. That'll help a lot. All right, and also you're going to need to dedicate a URL and a few pages to your app. You want to include FAQs so people can self-serve for the most common issues. And also you want to understand the impact of low memory on your app. And I suspect that most app crashes have to do with memory constraints or the failure to close a resource like the file system when you're finished working with them. Okay, so all of that to say this, the game plan in this lesson is, first of all, we want to perform some compliance testing on our app to make sure that it has a chance to be included in the store on the first pass. And then secondly, we're actually going to walk through the steps to submit our app to the store for what they call ingestion, all right? So to evaluate the readiness of our app for the App Store, we're going to use the Store Test Kit. This will automatically test a few scenarios and suggest other manual tests for you to conduct. Furthermore, it works as a checklist for items that you're going to need in order to submit your app to the store, like promotional images and things of that nature. So to open the Store Test Kit, you want to go to the Project menu and then go down to Open Store Test Kit about midway through. So this is going to open a new page in the main area, and you'll notice, first of all, that there are 3 tabs on the left-hand side: the Application Details, Automated Tests, and Manual Tests. And so the Application Details collects basic data about the app, including you'll have to give it a larger version of the main tile that'll be 300 pixels by 300 pixels. Now, if you use the phone store yourself, if you have your own phone and you've gone through there, you can see that each app has a page that's devoted to it with descriptive text and details about the publisher, a page with the ratings and the reviews for the app, and a page of screenshots. And so you're going to supply a lot of that information here, at least for the Store Test Kit, and then you'll obviously be supplying that information in the store itself. The second tab, Automated Tests, will perform a few tests to ensure the validity of the XAP, the Zap deployment package, and will ensure the images from the Application Details page are in place as well. And then finally, the Manual Tests tab will give you a number of suggestions for you to test your app on your own before submitting it. So they're not manual, and you can think of this more like a checklist. It passed it, it failed it, and so on. And so you have the name of the test, and then also the description of the test, the steps that you should take, and then there's obviously a little bit more information about that given test and the requirements that it satisfies for the App Store. Okay. So if you attempt to run the automated tests without doing anything, you'll see very quickly that first of all, the application package is not up to date. Recompile and try again. Change the solution configuration to release and perform any CPU to any CPU and rebuild the app. So that's the first thing that we're going to need to do here. We'll have a couple of issues that we'll need to correct, but the first one we needed to correct is that we're going to need to create a release version of our deployment package. So up to now we've been using a deployment or a debug version of our package, of our deployment package, which includes additional files that are used to sync up the execution of the code on the emulator or on our physical device with Visual Studio's debugging features so that you can set breakpoints, you can step through code, and so on. But now we need to create a release version. Now before I do that, I want to confirm that Visual Studio will create a release version successfully and that it's configured to be deployed to any CPU per the instructions of that little dialog that we saw a moment ago. So in the toolbar, what I want to do is go from debug, and I'm going to go down to the configuration manager. So the configuration manager dialog appears, and what we want to do is change the active solution configuration from debug to release. All right, and what I want to do is review the project contexts in the main area, ensuring that the configuration is set to release and the platform is set to any CPU. And once I've made sure that that's true, then I can go ahead and close this off and make sure that the release solution configuration is selected, and then I want to choose build solution. And if all goes well, the output window here at the bottom of Visual Studio will indicate whether it was successful or not. Hopefully it'll be successful and you won't need to fix anything, and we'll be completed with that step. Okay, so now that we have a valid release version of our Zap deployment package, we want to run the tests again. And this time I would expect the Zap deployment package to pass, but you can see we get some failures for iconography and screenshots. Before I set those, what I want to do is look for a button a little bit further down on that page. It says Start Windows Phone Application Analysis. And so if you click this button, that will add a new .sap file to Solution Explorer, as you can see right here, which is a blank performance log file that will capture data about the performance of your app as it runs. So the log file will then be poured over and reported on to let you know how well it runs in certain situations. Notice also that that SAP file is actually loaded here into the main area with a couple of options before you actually run the session that will monitor the app. So rather than spend the time talking about the different types of data and reports that you can generate from monitoring and profiling the options here, I'd recommend that you read what MSDN has to say about it. So take a look at this URL. But at this point, what I'm going to do is merely choose the app analysis monitoring option here at the top, and then I'm going to click the Start Session button. And the app will load into the emulator, and you'll see Visual Studio will display a monitoring message here in just a moment. Okay, so we'll want to go down to our soundboard app, and we'll begin clicking on sounds. We can try to record. This is just a test to see if it works for the 6th time. Stop recording, save it, whatever. Whoops, page down, whatever. Click OK. And I might do this for a little bit of while. I want to put the app through its paces and perform the typical use case scenarios. And perhaps even some edge cases and see what will happen. And then whenever we're finished testing the app, we want to click on this End Session link here at the bottom, and the collected data will be analyzed, and a report will be generated, as you can see here. And so you can see that we get some feedback. The app is responsive, the total amount of data that's being uploaded, memory used, and things of that nature. The report includes some interesting details about the app that could help you determine its readiness for the store. I think one of the most important things to look at is the battery consumption and the max memory that's used. But at any rate, now that I've completed this test, I'm going to make sure to ready the images that are needed for the store, such as, you can see here, a 300 by 300 store tile, and then also the screenshots for WVGA, WXGA, and the 720p. All right. So I've already gone through and done this for you. If you want to borrow mine, that's cool. They are in the same folder as the the soundboard assets. They're here, these store images, and you can see I have the soundboard, which is 300 by 300 pixel PNG, and then I have a number of screenshots. And I'll show you how I took the screenshots in just a moment. You might already know, I have figured out what I'm going to do. But essentially what we're going to do here is I'm going to go back into debug mode. And for each of the different screen sizes, for example, the WVGA, I'm going to load up that version of the emulator and run it. And then I'm going to go to the extra tools, and I'm going to go to the screenshot tab on the additional tools and select capture. All right, and then I would save that into a file location on my hard drive, and I would do the same for other the other screens or states of the app that I want to feature as screenshots in the store. All right, so that's how I would do that, is just take them in that manner. And then I repeat that process, like I said a moment ago, for each of the different screen sizes that I'm going to support in my app, for 720p and for WXGA as well. All right, so that's what I've essentially done here. And you can see I've taken 2 screenshots for each of the screen sizes. And you can use this if you want to try and submit your app to the store as well. So now let's go here to the store test kit, and I'm just going to begin to add them in. And I'll just go to, let's see, let's go to my documents, C9 Phone 8, soundboard assets, and what a little, because you're going to be opening this dialog up like a bunch of times, what you might want to do is just kind of create a link. You can just drag the folder from here, and I think you can just create it, yeah, like that. So now it's in your favorites, so you can get back here really easily from this point on. And then when you're done, using this folder, you can just right-click and then delete that favorite. That's a little tip. It saved me a little bit of time having to navigate through my documents every time I want to add another image to the store test kit. All right, so the first one we want to add is the 300 by 300 pixel store tile. So we got that. And then we're going to start by adding WVGA screenshots. So let's look for the WVGA 01. WVGA 02, and we'll just repeat that process for WXGA, WXGA 01, WXGA 02, and then the 720p, 720p 01, and 720p 02. All right. And now, let's go ahead and save all that. So let's go back to automated tests and rerun the tests. Oh boy, okay. Let's go ahead and set back to release and now rebuild the solution. And now hopefully that will satisfy all the tests. All right, and it does. Very cool. So I have manual tests that I need to consider, and it would be worth our time to go through all of these, but you can see there are a bunch of them, and I'm not going to do that for the purposes of this video. But if I were releasing a real product out into the Windows Store, I definitely would want to give these some thought. Okay. All right, so now I want to publish my app, and honestly, this is a multi-day process. I'm not 100% confident at this point that the app will even pass the first time. However, I do want to give you an idea of the submission process. It's really not that scary at all. It sounds scarier than it really is. So it's important to keep in mind that this site, the dev.windowsphone.com, changes often. So whatever I show you here is probably going to be different the next time you look at it. Just read the instructions and follow along. But let me give you some idea of how this will work. We're going to make sure that we're signed in, first of all. Okay. And then I'm going to go to the Publish tab, and then I want to submit an app. And you can see here that there's this checklist of items that we need to fill out. It contains a series of tasks, many of which are optional depending on the features of your app and how you hope to monetize it. All right, so I'm going to click on the App Info link, and that'll take you to the App Info page. And here I'm going to fill in some basic information like the name or the alias of the app. So a soundboard, and then I'm going to choose a category and potentially a subcategory. So I'm going to choose entertainment, and I'm going to leave the pricing at 0. I'll have some other options here like offer free trials. If I were charging money for this app, I might want to offer a free trial. If you're going to charge for your app as opposed to a freemium or advertising model, then are you going to allow for free trials? In some cases, this makes sense. In other cases, it might make less sense. So I hear that in general, trials do help sales, but I'm not sure that it really probably depends more on the type of app and your target audience. So further down on that page, you can see there's a market distribution option. The double chevron here for more options. You can see that we can choose to put it in the public store or choose a beta experience, which I recommended at the very outset. It might help to just invite individuals to use your app. They can download them through the store and use it and then provide feedback. It might be a great way to get some feedback before you actually try to sell your app. And then finally, further down on that page, we can have it automatically publish the app once it's approved, or you can choose to say, approve the app, but don't publish it right away. And that's the option that I want to choose, because I don't want this in the store since it's a freebie and I'm not ready to support it. I just want to show you what the process is of getting this into the store in the first place, or getting it approved. So the last option is to add an MPNS certificate. So that MPNS is the Microsoft Push Notification Service for Windows Phone. It allows you to send messages from a server to a user's phone securely. So imagine, for example, a long-running, massively multiplayer casual online game. So when the player's home planet is about to be attacked by another player, the game could notify that an attack is imminent, and this might be a premium upgrade in the game. It would give the player a chance to move his forces into place and get ready for the battle. But this service costs money, so you need to use it judiciously, and we're not talking about it in this series of lessons, but it's a cool feature if you ever need that type of rich integration with the rest of the phone, and I believe it'll work even for Windows 8 store apps as well. But since we don't need that, I'm just going to click Save. All right, so after you click the Save button, you're going to return to the Submit App page. You can see this first step is marked as complete, and now that opens up this Upload and Describe Your Zap. So let's go ahead and click that task. And here what we're going to want to do is to add a new Zap. So I'm going to click Add New. I'm just going to ask where it can locate it. I'm going to go to my Projects, Soundboard App, Soundboard Bin, Release, and I think that's what we want. The Soundboard Release anycpu.zap, and I'll click OK. And it might take a few moments to upload your Zap, especially if you have a lot of image or sound resources embedded in the Zap, and it might depend a lot as well on the speed of your internet connection. Okay, but once the Zap is uploaded, you'll see that it's analyzed and its details are displayed here below, with its capabilities, the English, the resolutions that are supported, and so on. I suspect it gets a lot of that information from the wmappmanifest.xaml file or .xml file. And further down, you can see where you can modify the Zap's store listing information. So, for example, you can create different versions of this, but we're only going to choose to change the English language, since that's the only one that we had selected for this app in our WM App Manifest. All right, but we got to create a description, so let me type this out. All right, and then you can specify some keywords that might be used as search phrases. So soundboard, sounds, maybe channel 9 in this case, because somebody might be looking for channel 9 apps. Soundboard with a space between sound and board, and I don't know, we'll just do a silly one, quack. Okay. Next, we're going to upload the images. First of all, we're going to add an app tile icon that's 300 by 300, and all we need to do is just click on the little plus in the middle of the gray area. And I believe this was in our Documents directory, C9 Phone. Oh yeah, right, we had the Store Images shortcut now. So I'm just going to use that and select the Soundboard 300 by 300 PNG. You can also choose a 1000 by 800 pixel background image, and that's used to further brand your store page. And so it might, here again, be great to get a graphic artist involved who can build, a background. And you'll see this for some of the more popular games. They'll have their own custom background in the store page, and it just makes it look like you've put a little bit more time into your app. Now you can see this option here. We can upload the WXGA screenshots, and then it will automatically create the lower resolution screenshots for the 720 and the WVGA. So I'm going to go ahead and leave that option selected, and I'll go here to C9 Phone, Store Images, and we'll choose WXGA01 and WXGA02. All right, and then finally I'm going to click the Save button. And this will return me to the Submit App page with the second task complete now. Awesome. Further down on this page, you see a bunch of optional tasks. Now in our case, we're not using Microsoft's in-app advertising platform, nor are we going to worry about customizing the pricing on a per market basis, so a different price for different countries or regions, nor are we going to need to enable the map service, which will provide actually some API credentials for use in our app. This last option, however, will be important if we were to build for the next app that we're going to build. If we were going to try to release that app into the store, we need to start here with some with getting credentials, and I'll actually reference this much later as we get to that point. But for now, we're just going to ignore that, and I'm going to click the Review and Submit button, and this review submission page is really your last chance to catch an error before you submit the app to the store for review. So nearer to the bottom of that page, you can see the option to either submit or go back and edit. I'm going to click the Submit button. And hopefully, if I do this right, if everything went smoothly, I will see the app submission successful page. Okay, so as the text says, it could take up to 5 business days, and you'll be notified via email whether your app is certified for inclusion in the store or not. Now, because of the magic of video editing, I waited for about 4 days and I received the email that you see on screen right now. Success. I had nothing up my sleeve. This was actually what we worked on. It worked, and so the good news here is it was a very simple process. We just had to supply a little bit of information, do a little bit of legwork, and we were able to submit our first app to the store. You won't see it in the store because I didn't release it into the store automatically. I'd have to go back and select and say, yes, I want that app in the store now, and I just chose not to do that. Okay, so basically, the recap for this lesson, the main takeaway for this lesson, was the thought process of testing and submitting, promoting, and supporting your app. And so there are some tools like the Store Test Kit that can help you get your assets all collected and ready for submission. But beyond that, you're going to want to get your app in the hands of others to try it and to provide feedback throughout the entire development process, as well as create a beta program for your app. These steps, along with good artwork, screenshots, good descriptions, and responsiveness on your part to your users after the sale, will help ensure the success of your app in the store. All right. So, seems like this series should be over by now, but it's not. We got a whole other app we're going to build, and so we're going to start on that in the very next lesson. We'll see you there. Thank you. Hi, I'm Bob Tabor with LearnVisualStudio.net. Now that we've finished our first app, let's move on to building a second app. This time we're going to build an app that's both location aware and social in nature. So it will use the phone's built-in GPS to determine where the current user is standing, and then use the latitude and longitude to search for photos that others have taken within a few meters of where our current user is standing. So how will we do that? We're going to call on Flickr, the social photo sharing website, to provide the data. Whenever you take a photo with a camera that supports geotagging, extra metadata is added to the photo that includes, amongst other things, the latitude and longitude, the position in the world where that photo was taken. So then when you upload photos to Flickr, it'll store that extra data and make it available so that others can search for photos based on a specific latitude and longitude. That's exactly what we're going to do. So our app should not only allow me to search for photos around me, but it should also let me pick my favorite Flickr photos from the ones that it brings up, and then choose those as lock screen background images. That would be really cool. And then, say every 30 minutes, it would change to another random one of the ones that I have selected. I think that would be a neat feature. So now that we have some ideas on maybe how it should work, let's spend a few moments mocking up how we want the app to behave. That will be the target that we'll build towards throughout the remainder of this series. So our game plan in this lesson is that we're going to start brainstorming using a low-tech mock-up to design the interactions and the screens that we want in our app. And then secondly, we're going to create a new project, and we're going to take some preliminary steps towards building our app by including a map control in our project and a couple of other things. Now, even though we haven't designed the app just yet, I anticipate that the map control will come into play at some point, so we're going to learn how to use it in this lesson. All right, again, we should spend some time thinking about the functionality of the app and about the interaction between the user and the app, how the information should be displayed to the user, and so on. And we're going to do that through, again, a low-tech mock-up using the templates that are available from Microsoft like we did in the previous app. So after some brainstorming, I came up with some good design ideas. Actually, these were all done by Clint in the first place, but let's just pretend that I did them for now, okay? So at any rate, if you take a look at the main page here, and hopefully you'll see a larger version of this on screen, the main page will show the user the map control, and it'll display the user's current position. And below that, there will be a text box where the user can optionally search for a phrase. So not only just the pictures around me, but the pictures around me that have some descriptive text that match some phrase, some search criteria that the user will be able to type in here before they click the search button on the app bar at the very bottom. So when the user clicks the search button on the app bar here at the bottom, we're going to make a call out to Flickr's web API. You can see I have that denoted with this little cloud at the very bottom. And so we're going to call their web callable API using the user's current locale, their latitude and longitude, as well as the little search phrase that they may have typed in here on the main page. And so then we'll get back a list of all the images that will finally then display inside of a grid. Then the user can select photos that they want, making multiple selections in that list of results, and then click a little button here at the bottom, and that will allow the application then to cache those photos onto its local storage and randomly use them as the lock screen image. So this will require we use a background agent to run about every 30 minutes or so. So now that we have a basic idea of the interactions that we want to enable, the functionality that we want in the app, and the basic screen elements that we're going to need, let's start building towards that design. All right, so you should be familiar with this process already. However, for the sake of completeness, let's go ahead and go File, New Project. We're going to make sure we are in C# Windows Phone Templates, and we want to select the Windows Phone app template here at the very top, and we're going to call this project Around Me because I want to see photos from others that took photos around me where I'm at right now. Okay, and we'll click the OK button. And we're going to target the version 8 of the Windows Phone operating system. And so the first thing that we're going to want to do is we are going to do something we haven't done yet, and that is go to the toolbox, and I want to drag and drop the map control from the toolbox onto the design surface. Now, when you do that, there are a few side effects, and you can see what happened to me here. In my case, I created a left margin of 349 and a top margin of 111. That's not really what I want, but I can easily edit that out in the XAML itself. It's for this reason that I prefer to work directly with the XAML, especially if I remember the name of the control that I want to use. However, in this particular case, and let me resize a few things here. We'll choose Fit Selection. There we go. In this particular case, I want you to take a look at the code that was added up here near the very top. You can see that we get this XML namespace maps. All right, so by dragging and dropping the maps control, a XAML namespace was added to the XAML document. This is necessary because the maps control lives in a different namespace and assembly from the other controls that I've been using. But nonetheless, I now have a map control. I want to edit it to simply sport a name attribute and get rid of all of this margin information and so on. Vertical alignment, we're going to get rid of all that. Horizontal alignment. We just want simply a map with a name. And I'm going to call this the Around Me map. All right, there we go. You can see by removing all of that positional information, it just centers the map here in my content panel. Very cool. All right, now if I were to try and run the app at this point, And as you can see, we have an exception that's thrown here. We've seen something like this in the previous project when we had some problems with our XAML, right? So we see here a first chance exception of type system.windows.markup.xaml parse exception. Okay, so what could this possibly be? I mean, we didn't really add all that much XAML to our project. Well, the problem is that the map control, let me stop this. The map control requires the mapping and location capabilities of the phone to be declared, and we've not told the Windows Phone operating system that we want to use those capabilities in our app. The mapping functionality of the Windows Phone 8 operating system has changed dramatically from the previous version that was based on Bing Maps. The new mapping features were built in conjunction with Nokia and are more integrated into the phone's operating system than before in an effort to make the maps more performant. So this is why we need to request permission to use this capability of the phone. It's now a core feature of the phone. So to learn more about the rationale for the changes to mapping in Windows Phone 8, take a look at this blog post, this Windows Phone team blog post. So to remedy this, what we're going to need to do is to make some changes in the wmappmanifest.xml file. So we're going to open it up and we're going to go to the Capabilities tab, and I want to make sure to select the location and map capabilities. So make sure you've got both of these checked. Okay? And then let's go ahead and just rerun the app. So as you can see, the map control appears, but it's at a very high level because no location is set. We'll actually do that next. So let's stop, and then in the map mainpage.xaml.cs file, let's go here, and we're going to go loaded. So we're going to on loaded for our main page. We're going to add the main page loaded event handler. So I'll hit tab, and then here I'm going to create a call to a helper method. And the reason I'm creating a helper method is because I anticipate that I'm going to reuse this functionality I'm about to write in another file later on, and I'm just preparing for that eventuality. Okay, so let's, in the update map, let's go around me map dot set view, and there are quite a few overloads for this. What we want to do is choose this overload. It's the fourth one, at least on my version of Visual Studio, where we give it a geo-coordinate for the center, and then we give it a zoom level. All right, so a geo-coordinate is just a class, so geo-coordinate, and it comes from system.device.location. I'm going to go ahead and hit the escape key on my keyboard because I don't want it to auto add all of that. We'll add a using statement in a little bit. Geo-coordinate, and then we'll give it also a zoom level. And so here, I'm just going to type in 17D, and I'll talk about that in just a minute. Okay. So in this new geo-coordinate, let's go ahead and add the using statement so we get IntelliSense help here. So using system.device.location, great. Let's give it then a latitude and a longitude. So I happen to know which one I want to work with, and I'll explain this in a little bit. And comma, longitude will be minus 87.6231D. Okay. So the setView method combines several property settings into one convenient call. So we pass in this geo-coordinate class that's hard-coded to a specific place, and that place happens to be in Chicago. I'll talk about why I picked Chicago a little bit more in a moment. And then now that we have given it the center point that we want to view, then we're also going to give it a scaling factor of 17. And you can experiment with these numbers, but 19 is zoomed in really close and 5 is zoomed really far out. So I picked 17 because that's a good middle point. By the way, you'll notice that I suffixed each of these values with the capital letter D, which is for double. It's just a way to ensure that we're working with double literals, okay? I think you can leave these off and you'll be fine, but it's just a habit that I've gotten into. So now I want to test to make sure that this works. All right, and you can see we're zooming in quickly into a specific point here, You can see the text, the John Hancock Center, next to Water Tower Place, next to Loyola University downtown, all kinds of good stuff. All right, and so that's why I wanted to pick this, because that spot's pretty important to me. Okay, but at any rate, let's stop right here. We've made some good progress already as we've gotten started. To recap, the big takeaway from this lesson is how to use the new map control in the Windows Phone 8. We're going to become even more familiar with it as we go through these lessons, but at a minimum, we know that it requires that we set a capability or two in the wm-app-manifest.xml file. We also learned how to change the focus of the map like we did just now and the zoom level. And we learned about the geocoordinate class and that it represents a position on the globe based on its latitude and longitude. And we still need to learn how to retrieve the current position of the phone. And we're going to do that soon, but this is a really good start. So we'll pick it up in the next lesson. We'll see you there. Thank you. Hi, I'm Bob Tabor with LearnVisualStudio.net. In the previous lesson, I was able to hard code a geocoordinate object and pass it to the map control in order to set its position, like you see right here on screen. However, for our app, we'll want to retrieve that information from the phone, not just hard code it, okay? The Windows Phone API has a geolocator class that will use the phone's GPS system to determine where in the world it is right now. So here's the game plan for this lesson. We're going to experiment with our update map method to learn about the geolocator class, how to set its accuracy and obtain the current position. We're going to learn about other classes in the Windows Phone API that allow us to work with the map and the locale of the user. Then we're going to configure the Windows Phone emulator and set its position to a specific place, namely the John Hancock Center in Chicago. I have a special affinity for Chicago and for that building in particular, and I'll tell you about that a little bit later. So at any rate, we're going to pick up where we left off in the previous lesson. Let's go ahead and stop the running of our app, and we're going to focus on this update map helper method. And what I'm going to do is I'm going to add a bunch of code here, and then I'll explain what we're doing. First thing I'm going to do is just comment out what we've already done. And the intent here is for us to actually use the phone's current position to tell us the latitude and longitude and give that to the map rather than hard code it like we've done here. So let's go ahead and get started. Okay, so hopefully it's kind of obvious here what I set out to do. I'm going to create a geolocator class instance, and that will allow me to use the functionality in the phone to determine the latitude and the longitude. So we'll get return from this get geoposition async method a position, and we'll use that position to get the coordinates, the latitude and the longitude, and we'll use that to create a new geocoordinate. So essentially here we're having to convert from what the phone can give us to what the map needs. So that's why we're kind of changing from a geolocator to a geocoordinate. All right. So at this point, I'd like to point out why we go in and set the desired accuracy in meters. Why do we need to set the desired accuracy? Well, the best article that I read on the process of acquiring the geoposition of the phone and why there are several factors to consider is this blog post that you see on screen right now. It's a blog post on the Windows Phone Developer blog by Daniel Estrada Alva, who was a software development engineer on the Windows Phone team. And so I will just kind of leave you to that, but it's not quite as straightforward as just saying, hey, give me an absolute position. There's several things to consider. All right. Next up, there's a keyword that you may not be familiar with here in line number 41, the await keyword. And if you'll notice when I typed it, I got some red squiggly lines and I hovered my mouse cursor over it, and I had to add this keyword async at the very top of this method let's see, line number 35. Just how this works and why it works and what's going on here, I'd like to save that topic for a later lesson. I promise you I will spend an entire lesson just on the await and async and task keywords, okay? So let's just hold on to that. For now, just understand that the purpose of this is to keep our application responsive while potentially long-running tasks are executing. In this case, the phone could take a long time to acquire the current location using its built-in GPS hardware. So while it's acquiring the location, the user's phone and even our app should continue to be responsive to the user's input. Again, more on that a little bit later, okay? So then, again, we're converting from this geolocator, getting the position, and then turning it into a geocoordinate that can work with our map. The geoposition object has a collection of coordinates, as you can see right here. And the 2 coordinates, latitude and longitude, we pass those to create a new geocoordinate, which we can give to the set view method now, along with the scale factor. And so when we run the app this time, you can see the result is that the map is zoomed into Redmond, Washington, the home of Microsoft's main campus. So this is the default position of the Windows Phone emulator, all right? And so that's why we're zoomed in here. So how do we change the emulator to use a different latitude and longitude? Well, if you recall, there is some functionality in the additional tools, and we can select the location tab, and I'm going to type in the John Hancock Chicago and then do a search, and it brings me to that position in Chicago right at the John Hancock Center. And so what I want to do is use my primary mouse button and add a pin right on top of the John Hancock Center. And you can see that it now gives us that latitude longitude of 41.8988 and minus 87.6231. Okay, great. And so by adding a pin, I've set the current location to the correct latitude and longitude for the John Hancock Center. However, sometimes it takes a while for the phone's GPS to catch up and refresh. And so what I found works the best is to exit out of the Around Me app by hitting the Start button, and then go to the Windows 8 phone application list and go down to their Maps app. And I'll go ahead and say allow the Maps app to use the current location. And you'll see we start out in Redmond, but then we quickly jump way over to Chicago. Perfect. All right, and so now, once it's done loading, I should be able to go back to the Start menu, go back to our Around Me app here in my application list, click the Around Me app, and now even our Around Me app will center on the John Hancock Center. Awesome. Okay, so great, it works. Just to recap, the big takeaway from this lesson is how to use the geolocator class to interface with the phone's GPS hardware to retrieve an instance of the geoposition class. The geoposition class has a number of interesting details, but for our purposes, we only care about the longitude and the latitude, which we can use to construct a new geocoordinate class, which is what the map control needs. so that we can set the view on that instead. And we learned how to configure the phone emulator's location to make it think that it's at a specific place in the world in order to test various location scenarios like we've done here. Okay, so that wraps up this lesson. We'll see you in the next one. Thank you.